Hello. In this example, we are looking at finding the integral of x minus 10 over x minus 2 times x squared plus 4. And we want to use this process of partial fraction decomposition. So, using this process, first, we want to make sure the denominator is completely factored. The x minus 2 cannot be factored anymore, but we want to check that x squared plus 4. X squared plus 4 is an irreducible quadratic. There are no zeros to x squared plus 4. There's no value of x that would make that 0. So we can't break this down any smaller. There's no real value of x that will make that 0. So this is as far as our partial fraction decomposition, or as small as our denominator can be factored. So we want to set up our partial fraction decomposition with the first rule that every factor will get a fraction. So we have the factor of x minus 2, and that gets a fraction. And we have the factor of x squared plus 4. That also gets a fraction. Now, we saw in the last example, if we have a linear, like x minus 2, we can put a constant above it, just an a. There's our unknown coefficient for that. But in x squared plus 4, if we just put a constant above it, there are some terms we'd be missing out on if we combined like terms. As an example, 1 over x minus 2 plus x over x squared plus 4, if we combine that together, that is not the same as 1 over x minus 2 plus 1 over x squared plus 4. Despite the fact that we'd have the same coefficient, and we can't simplify those down any farther. So, because these are not the same, we have to put a linear above the quadratic. So when we put a linear above the quadratic, that is a bx plus c. Something x plus something else. We're going to have two coefficients above the quadratic term. So since we have a squared, we put two coefficients above. So there's our partial fraction decomposition. Multiplying everything by this denominator, this x minus 2 times x squared plus 4, multiplying that on, when we multiply the left-hand side, that's going to clear out that denominator. X minus 2 divided by x minus 2 goes away. X squared plus 4 divided by x squared plus 4 goes away. So we get x minus 10 on the left-hand side. For the right-hand side, when I multiply, the x minus 2 and x minus 2 will cancel when I multiply by a to get a times x squared plus 4. And when I multiply by the bx plus c, the x squared plus 4s will cancel, and we'll be left with an x minus 2. Now, in this one, we're going to see another technique for how we can solve for a, b, and c. The last time, we took very nice values of x and plugged them in to get three coefficients, these a, b, and c. In this one, I'm going to multiply it all out. And I get x minus 10 equals ax squared plus 4 times a plus bx squared minus 2bx plus cx minus 2c. Now, we know from algebra that if I wanted to simplify this side down, I would combine like terms. I'd notice, hey, I have an x squared and an x squared. I could add those together to be a plus b times x squared. I have an x and an x, I could combine those together to be c minus 2b times x. And then I have things without x's. I have a 4a and a 2c, and so I could combine those together. And each one of these, since a, b, and c are just representing number, each of these expressions in parentheses are a number. But this expression is equal to x minus 10. Meaning, when I take together my a plus b, it needs to equal the x squareds on the left-hand side. There's no x squareds over there. So a plus b has to be 0, because there's no x squareds. C minus 2b is what makes up the x term. Well, there's only one x over here, so c minus 2b equals 1. And last, the 4a minus 2c, that is a number without any x's. That's my constant term. So 4a minus 2c is equal to negative 10. I now have 3 equations with 3 unknowns we can solve. A plus b equals 0 means that a equals negative b. And c minus 2b equals 1 means that c equals 1 minus 2b. Or plus 2b. I'm going to take these 2 equations and put them into this last one to get 4 times negative b minus 2 times 1 plus 2b is equal to negative 10. Now I have an equation with just b. Working this out, we get negative 4b minus 2 minus 4b equals negative 10. Combining the b's together is negative 8b. And adding 2 to both sides, move this 2 over with the negative 10. Negative 10 plus 2 is negative 8. This means b equals 1. We know a equals negative b. So a equals negative 1. And last, we know c equals 1 plus 2b. b is 1, so 1 plus 2 times 1. c is 3. There's our a, b, and c. Zooming out, that means for the partial fraction decomposition we started with, getting rid of our multiplication that happened, these fractions are really a, which is negative 1 over x minus 2, plus b is 1, so 1 times x is 1, x, and c is 3. If I were to go through the process of combining fractions and combine that all together into 1 by multiplying by the opposite denominators, I would get back to x minus 10 all over x minus 2 times x squared plus 4. So if I want to integrate x minus 10 all over x minus 2 times x squared plus 4, that would be the same as integrating -1 over x minus 2 plus x plus 3 over x squared plus 4. There's going to be 3 fractions here that we can integrate. We'll have -1 over x minus 2. And breaking up this fraction, we have the integral of x over x squared plus 4. And the integral of 3 over x squared plus 4. This one, so the u sub here, if we make u equal x squared plus 4, du equals 2x dx, or 1/2 du equals x dx. This integral will become 1/2 the integral of 1 over u du. The other two we can integrate with very little work. The first one, the integral of -1 over x minus 2 is negative natural log of the absolute value of x minus 2. The integral of 1 over u is the natural log of the absolute value of u times that 1/2 out front. And then the integral of 1 over x squared plus 4 is 1/2 arctan of x over 2 by our arctan formula. That is being multiplied by 3. So simplifying some things down and replacing back our u, we get the negative natural log of the absolute value of x minus 2 plus 1/2 the natural log of the absolute value of u, x squared plus 4, plus 3/2 arctan of x over 2 plus c. So some really fast integrals once we do the partial fraction decomposition. We will take a look at some more examples in the next video, the next few videos, of things we can do with partial fraction decomposition.